that d by dx of x power n is equal to n into x power n minus 1. So this is a differentiation formula. Okay. So here we have to prove d by dx of x power n is equal to n into x power n minus 1. Okay. We can prove all differentiation formulas. Okay. All derivative formulas using first principle of derivative. So we can prove this formula by using first principle of derivative. Okay, now so using first principle of derivative we can derive all derivative formulas. మొత్తం డిఫరెన్షియేషన్ టాపిక్ లో ఉన్న ఫార్ములాస్ అన్ని కూడా ఈ ఫస్ట్ ప్రిన్సిపల్ ఆఫ్ డెరివేటివ్ యూజ్ చేసుకొని మనం డెరైవ్ చేస్తాం. ఓకే, వెరీ సింపుల్. సో ఫస్ట్ ప్రిన్సిపల్ ఆఫ్ డెరివేటివ్ ఈజ్ లిమిట్ ఆఫ్ ఫంక్షన్ f of x plus h minus f of x by h as h approaches 0. So this is first principle of derivative. This expression is called first principle of derivative. So using this first principle of derivative we can derive formula for d by dx of x power n. So d by dx of x power n means rate of change of x power n, okay, no, with respect to x. Rate of change of x power n with respect to x. Derivative of x power n with respect to x, okay, na, is n into x power n minus 1. So we have to prove this n into x power n minus 1. At last we should get n into x power n minus 1. Okay, first of all here f of x is, here my function is f of x is equals to x power n. Okay, na? So exponential function. So f of x is equals to x power n. So my function is in exponential form. Okay, na? So this formula actually called power formula. This formula is called power formula of differentiation. Power formula of differentiation. Derivatives. Okay. So f of x is equal to x power n. Okay. What about f of x plus h? So how do we get f of x plus h? We have f of x. So how do we get f of x plus h? Simply replace x by x plus h. So f of x ఉంది నాకు, f of x plus h కావాలి. So ఏం చేస్తాను? Simply replace x by x plus h. So f of x plus h is equals to, so replace x by x plus h. x plus h పెట్టండి ఏమవుతుంది? x plus h whole power n. Now use this formula. Okay, now use this first principle. Limit h approaches 0. f of x plus h means x plus h whole power n minus f of x means x power n by h. Limit h approaches 0. Now look at numerator, x plus h whole power n. It's like x plus y some whole power n. So we can expand this expression using binomial expansion. Apply binomial expansion formula. X plus h whole power n is equal to nc naught x power n h power 0 plus nc1 x power n minus 1 h power 1 plus nc2 continuation plus nc2 x power n minus 2 okay, h square plus so on, okay, plus so on, minus x power n minus h, x power n whole divided by h. Limit h approaches 0. nc naught value how much? 1. nc naught binomial coefficient, nc naught value 1. h power 0 1. So 1 into x power n you will get x power n plus nc1 into x power n minus 1 into h plus nc2 x power n minus 2 into h square, okay, plus so on minus x power n, minus, here we have x power n, whole divided by h, whole divided by h, plus x power n minus x power n get cancelled, plus x power n minus x power n get cancelled, and finally limit h approaches 0. See, and in second term, third term, in remaining, in all the terms, in all, observe all the terms, here we have h, here we have h square, and next term we will get h cube, and next h power 4, and so on. Okay, so in all terms h is common, so take out h as a common factor. If you take out h from all the terms, n-1 value n into n-1 value n into x power n minus 1, h already common, plus here also take out h common, nc2 x power n minus 2, so one h common means you will have one more h, plus so on by divided by h, numerator h, denominator h get cancelled. So after taking h from all the terms, so numerator h and denominator h get cancelled, here h common, and we will get nc1, so nc1 value n, so n into x power n minus 1, here we have got nc2 x power n minus 2, one h common, so one more h will be there, and plus, and so on. Next you will get h square term, and next h cube term, h power 4 term, and so on. Okay, so limit h approaches 0, put h is equal to 0 now, put h is equal to 0. If h is equal to 0, so 0 into this term will be 0, and next 0 square 0, next term also 0, in remain all the terms will be 0, because in all terms we have h term. Okay, so put h is equal to 0, so all terms will be 0, and we left with n into x power n minus 1, only we left with this term, n into x power n minus 1. Therefore dy dx of x power n is equals to n into x power n minus 1. Okay, so not only this formula, we can derive all derivative formulas using first principle of derivative.